Assalamualaikum and hi guys. This video is for our group assignment for course SEEE3533 Communication Principle. The objective of this video is to give you some basic knowledge and information about the Ericsson Educate Tech Traveler Camp. We are from Group 6 and these are my team members. First, Nur Rabiatul Adawiyah binti Abdul Hamid. The second one, Nurul Atikah binti Azaman. Third one, Nurul Haidah binti Naharuddin. And the last one, Wan Muhammad Adli bin Wan Muhammad. For the presentation outline, we start with amplitude modulation that will be presented by me, Wan Adli, follow with angle modulation by Nurul Atikah, radio digital modulation by Rabiatul, and the last one, the tutorial game by Haida. Okay, for my topic, introduction of amplitude modulation. Amplitude modulation is a process by which the wave signal is transmitted by modulating the amplitude of the signal. It is commonly used in transmitting a piece of information through a radio carrier wave. Amplitude modulation is mostly used in the form of electronic communication. These are the types of signal in amplitude modulation. First, message signal, the first one, and the second one is carrier signal. And if we mix these two signals, it will produce amplitude modulated signal. Okay, the next one is block of amplitude modulation. Okay, this is the block diagram for amplitude modulation. First, modulated AM modulated signal. Modulating signal VMT with equation EM cos omega MT will pass through the modulator, and the carrier signal VCT with the equation EC cos WCT that will change its amplitude to generate specific modulated AM signal VAMT. Next, I will explain to you about amplitude demodulation. Amplitude demodulation is the process of recovering the modulating signal or the information signal. Demodulation is performed by the demodulation circuit, which is also known as the detector circuit. This figure shows that the block diagram for amplitude demodulation. The next one is envelope detector. Envelope detector is the simplest and the most economic detector for amplitude modulation signal. Envelope detector, also known as rectifier detector or diode detector. The cost of the envelope detector is very efficient. It is simple to implement and no need to generate local carrier. I will explain to you a little bit about how the envelope detector functions. First, the original signal is located at the modulated signal. The modulated signal will pass through the diode and then go to the low pass filter LPF and then go through the block detector part. Then finally, it will produce modulating signal.
This is the basic knowledge about angle modulation. Angle modulation is a process by which the angle, frequency or phase of the carrier signal is changed in accordance with the instantaneous amplitude of modulating or message signal. As we know, angular modulation can be classified into two types, such as phase modulation (PM) and frequency modulation (FM). For phase modulation (PM), PM implies that the phase deviation of the carrier is proportional to the modulating signal, like this question, where is Kp is the phase deviation constant. So we will get this equation. For frequency modulation FM, FM implies that the frequency deviation of the carrier is proportional to the modulating signal. This, where Kf is the frequency deviation constant. So we will integrate this equation and then we will get FM signal equation. This is relationship between FM and PM. As we can see, FM signal can be generated by using PM modulator. So on with PM signal, it can also generate by using FM modulator. So from all block diagram, it can be shown that generation of FM and PM signal are actually related to each other. This is relationship FM demodulator and PM demodulator. Demodulation process is used to get back the information signal. For FM demodulator, in order to get back the information signal from FM signal, so that PM modulator it will use and the signal it pass through differentiator. In contrast, for PM demodulator, FM demodulator is used and the signal it pass through the integrator. This shows that close relationship between FM and PM. This is FM and PM signal in time domain. When modulating signal undergoes FM modulation, it will generate this kind of modulated FM signal. So, at positive peak of modulating signal, it will generate FM signal to have a higher frequency. But at negative peak of the modulating signal, it will cause the FM signal to have the lower frequency. For PM modulated signal, when PM generator will have higher frequency. For PM modulated signal, PM generator will have higher frequency when the modulated signal is at the rising signal, but when the modulated signal is falling, so the phase modulated signal will have the lower frequency.
Okay, I will present about radio digital modulation. For the digital transmission, all signals from the previous modulation or coding method normally are not transmitted in their original form, which is baseband signal. So they will modulate a carrier that is suitable with the channels used. So digital signal can also be transmitted through free space if the analog carrier signal is used. So there are three techniques that can be used, which are amplitude shift keying (ASK), frequency shift keying (FSK), and phase shift keying (PSK). So historically, the term of shift keying refers to breaking a circuit using a key to shift current value from 0 to 1. Amplitude shift keying. So amplitude shift keying is a type of amplitude modulation which represents the binary data in the form of variation in the amplitude signal. So any modulated signal has high frequency carrier. So the binary signal when ASK modulated give a zero value for low input, while it gives the carrier output for high input. So the following figure represents ASK modulated waveform along with its input. So to find the process of obtaining this ASK modulated wave, let us learn about the working of the ASK modulator. So the ASK modulator block diagram comprises of the carrier signal generator, the binary sequence from the message signal, and the band limited filter. Following is the block diagram of the ASK modulator. So the carrier generator sends a continuous high frequency carrier. The binary sequence from the message signal make the unipolar input to the high or low. So the high signal causes the switch, allowing a carrier wave, hence the output will be the carrier signal at high input. When there is low input, the switch open, allowing no voltage to appear, hence the output will be low. The band limiting filter shapes the pulse depending upon the amplitude and phase characteristic of the band limiting filter or the pulse shaping filter. ASK demodulator. So there are two types of ASK demodulation techniques. There are asynchronous ASK demodulation and synchronous ASK demodulation. So the clock frequency at the transmitter when matches with the clock frequency at the receiver, it is known as a synchronous method. As the frequency gets synchronized, otherwise it is known as asynchronous. So the asynchronous ASK detector consists of a half-wave rectifier, a low-pass filter, and a comparator. Following is the block diagram for the same. So the modulated ASK signal is given to a half-wave rectifier, which delivers a positive half output. The low-pass filter suppresses the higher frequency and gives an envelope detector output from which the comparator delivers a digital output. Next is synchronous ASK demodulator. So synchronous ASK detector consists of a square law detector, low pass filter, a comparator, and a voltage limiter. So following is the flow diagram for the same. So the ASK modulated input signal is given to the square law detector. So a square law detector is one whose output voltage is proportional to the square of the amplitude modulated input voltage. So the low pass filter minimizes the high frequency. The comparator and the voltage limiter help to get clean input output. Okay, so noise or error in digital communication system is measured using bit error rate, BER. So BER is measured based on the difference between the send and receive bit in period T. So normally, the BER will depend on the factors such as the modulation techniques and SNR, as shown in figure. So SNR is EV over with NO. EV is energy per bit and NO is noise power spectrum density, meaning single-sided. For ASK, this PE is equal to half ERFC square root of EV over 4 NO. So EV is the average energy per bit and NO is the noise power spectrum density per band. Okay, next I will explain about frequency shifting. FSK is the digital modulation technique in which the frequency of the carrier signal varies according to the digital signal changes. FSK is the same of frequency modulation. So the output of FSK modulated wave is high in frequency for a binary high input and is low in frequency for a binary low input. So the binary 1 second and 0 second are called mark and space frequency. So the following image is the diagrammatic representation of FSK modulated waveform along with its input. So to find the process of obtaining this FSK modulated wave, let's know about the working of FSK modulator. So FSK modulator. The FSK modulator block diagram comprises of two oscillators with a clock and the input binary sequence. Following it is this block diagram. So the two oscillators are producing a higher and lower frequency signal are connected to switch along with an internal clock to avoid the abrupt phase discontinuities of the output waveform during the transmission of the message. A clock is applied to both the oscillator internally. The binary input sequence is applied to the transmitter, so as to choose the frequency according to the binary input. Okay. There are different methods for demodulating a SK wave. The main methods of SK detection are synchronous detector and asynchronous detector. So the synchronous detector is a coherent one, while asynchronous detector is a non-coherent one. So for the asynchronous FSK detector, so the block diagram or asynchronous FSK detector consists of two band pass filter, two envelope detector, and a decision circuit. Following is the diagrammatic representation. So the FSK is passed through the band pass filter VPF, turned to phase and mark frequency. So the output from these two VPF look like ASK signal, which is given to the envelope detector. So the signal in each envelope detector is modulated asynchronously. So the decision circuit chooses which output is more likely and select it from any one of the envelope detection. So it also reshapes the waveform to a rate. For the synchronous FSK detector, so the block diagram of synchronous FSK detector consists of two mixers with two local oscillator circuit, two band pass filter, and decision circuit. Below is the diagrammatic representation. So the FSK signal input is given as the two mixers with two local oscillator. So the FSK signal input is given to the two mixers with two local oscillator circuit. So these two are connected to two band pass filter. So this combination acts as demodulator, and the decision circuit chooses which output is more likely and select it from any one of the detectors. So the two signals have a minimum frequency separation. For both of the demodulation, the bandwidth of each them depends on their bit rate. So the synchronous demodulator is a bit complex than asynchronous type demodulator. The next is about phase shifting. So PSK is a digital modulation technique in which the phase of the carrier signal is changed by varying the sine and cosine inputs at a particular time. So PSK technique is widely used for wireless LANs, biometric contactless operations, along with RFID and Bluetooth communication. So PSK is two types depending upon the phases the signal gets shifted. So there are two types of phase shifting. So there are binary phase shifting, PSK. It is also called as two-phase PSK or phase reversal keying. In this technique, the sine wave carrier takes two phase reversals such as 10 degree and 180 degree. So BPSK is a double sideband suppressed carrier, the SBC modulation scheme for messaging the digital information. So next is quadrature phase shifting PSK. So this is the phase shifting technique in which the sine wave carrier takes four phase reversals such as 0 degree, 90 degree, 180 degree, and 270 degrees. If this kind of techniques are further extended, PSK can be done by 8 or 16 values, also depending upon the requirement. So QPSK is a variation of BPSK. So and it is also a double sideband suppressed carrier, the SPSC modulation scheme, which sends 2 bits of digital information at a time, called as digits QPSK modulator. So the QPSK modulator uses a bit splitter to multiply with the local oscillator and the summer circuit. Following is the fault diagram for the same. So as the modulator's input, the message signal even speed are second bit, fourth bit, and sixth bit, and odd speed, which are first bit, third bit, and fifth bit, are separated by the bit splitter and multiplied with the same carrier to generate odd BPSK called as PSK1 and even BPSK called as PSKQ. So the PSKQ signal is anyhow phase shifted by 90 degree before being modulated. So the QPSK waveform for 2-bit input is as follows, which shows the modulated result for different instance of binary input. For the 00, it is phase shifted by 0 degree. 10 is shifted by 180 degree, 01 is shifted by 90 degree, and the 11 is shifted by 270 degree. The next is QPSK demodulator. So the QPSK demodulator uses two product demodulator circuit with local oscillator 2-band pass filter, and a 2-bit parallel to serial converter following in the diagram contained. So the two product detectors are at the input of the modulator simultaneously demodulate the two BPSK signals. So the pair of bits are recovered here from the origin data. So these signals after processing are passed to the parallel to serial converter. So that's it for radio digital modulation. Thank you.
Now we will watch a guidance video of the mission for Erisson Tech Traveler game. Here we go. Insert your email. And select your country. Click a single mission and choose Mission 4.
Mission 4, Data Communication. In this mission,
and then you can continue your game. This QR code will bring you directly to the game. Now it's your turn to enjoy and participate in it. That's all from us. Thank you.